Welcome back, 6th graders. Did you enjoy your little day off that you had? I didn't get a day off, but I sure was thinking about you a lot, wondering what you guys were doing. We're doing now exponents. I think you're going to like it because it's a pretty simple concept. We're in module 10, so we're moving right along in our little book. Exponents. I don't know how much experience you have in elementary school with exponents, but it's repeated multiplication. So what I want you to do is go ahead and set up your Cornell notes. This way, if you need to pause and write it down, you can. Exponents, repeated multiplication. I'm trying to be really careful with my new stylus because I noticed that the last time I made a video, I was like really tapping hard, and it doesn't come out that loud when I'm doing it at the time, but when it's recording, the noise is like super loud. Alright, so exponents is repeated multiplication. Remember that multiplication is repeated addition. There's a big difference. Repeated addition. Okay? So remember, you can pause to write down these notes because I'm going to move kind of fast. That's the thing about watching the videos, is that you can pause and rewind to listen again if you need to. I'm going to be checking your notes, so if you don't have these notes, I will be making you do it in class. And these Cornell notes are things that you can be doing at home. This is the easy stuff. You're just taking notes. You're watching a video and you're taking notes. Don't spend class time doing that. That's easy. Spend class time doing the dashboard assignments, because that's what sometimes you need help on. Okay, so, whoops, wrote with my finger. Identifying repeated multiplication. Okay, you're going to go ahead and copy these problems into your notes. A scientist observed the hourly growth of bacteria and recorded his observations in a table. So at 0 hours, there was only 1 bacteria. And then after an hour, it had doubled. So now there were 2. Okay, there was 1, it doubled, and now there was 2. Okay, after 2 hours, each one of those bacteria doubled. So that means there were how many? 2 and 2 is 2 times 2. That's 4. Okay, and then 3 hours later, so each one of those bacteria doubled. So now we've got like really sick bacteria everywhere. So that's 2 times 2, which is 4, and then 4 times 2, which is 8. And if you go up here and look, there's 1, 2, 3, 4, 5, 6, 7, 8 bacteria now. Okay, now some students are going to forget that this is repeated multiplication, and they're going to add these. If you take 2 plus 2 plus 2, that actually equals 6. Much different answer than 8. Okay, we don't want to be adding over and over again. We're not taking 2 times 3. We're taking 2 times 2, and then that answer times 2. So let's do one more. After 4 hours, okay, 2 times 2 is 4. 4 times 2 is 8, and 8 times 2, 16. So A says, complete the table. What patterns do you see in the total bacteria column? So we look at the total bacteria, and each time it's doing what? It goes from 1 to 2 to 4 to 8 to 16. we can say each hour, yes, you're supposed to be putting this in your notes, the bacteria doubles. This is a complete sentence. Make sure that you have capital E and you're using punctuation. If you want to use an exclamation point on that because you're like, wow, that is crazy incredible, we'll do that. Okay, complete, whoops, complete each statement. Maybe we need the table to do that. At 2 hours, the total is equal to the product of 2 2's. Okay, remember product is the result of multiplication. At 3 hours, the total is equal to the product of, how many 2's are here? There's 3 of them. 3 2's. And at 4 hours, the total is equal to the product of 4. If you want to write it in cursive, that's how that would look. 4. So let's reflect on this. How is the time in hours related to the number of times 2 is used as a factor? Okay, so the number of hours is the same as the number of times we multiply the bacteria. Okay, so I'll write the number of hours. Let's use some more math vocabulary here. The number of hours is the same as the number of times two is used as a factor. My husband said I have bad handwriting with the stylus. Okay, moving on. Okay. This is using exponents. So it says a number that is formed by repeated multiplication by the same factor is called a power. You can use an exponent and a base to write a power. For example, 7 and then with the little 3 there means the product of 3 7s. 7 times 7 times 7. It says the base is the number that's multiplied. So here the base would be 7. And in the exponent, it tells us how many times the base appears in the expression. Okay? So you're still writing notes on in your Cornell notes. I want you to write the word expression, and then you're going to write things like 3 plus 5, 2 times x. No, let's not use x. Let's use something else because it looks like a time sign. 2 times m. Okay? These are expressions. There's no equal sign. It doesn't tell you what it equals. It just tells you the little math problem without the equal sign. Here they have an equal sign, but they're only talking about this piece of it. So the exponent tells us how many times the base appears in the expression. Let's look at this table. 6 with the little 2. This is how you say that. There's different ways to say it. When it's a 2, you would say squared. So that's 6 squared. Or you can say it 6 to the power of 2. Sometimes we say 6 to the second power. Or here this is like complicated. I would never say it. 6 raised to the second power. I would leave off the raised and just say 6 to the second power. But anyway, when you have the little 2 here, that you are going to be hearing the word squared a lot. Okay, and the reason is when you think about a square and you're going to find the area of it, okay, the area of a square, area equals length times width. Or sometimes they say area equals side squared. That means you take 5 times 5. It's the same number multiplied twice. That's an S, not a 5. Side squared is how they say that. Yes, put this in your notes. Draw this out. You don't need to put this table here. All right, so when it's a 3, that's cubed. We would say cubed. And the reason it's cubed is because when you draw a cube, do that. Go ahead and draw. It's 2 squares that overlap, and then you connect the corresponding corners, the top left to the top left. I know people make better cubes than I do. Okay, anyway, if you're going to find the volume, this right here was area. If you're going to find the volume, let's say all the sides are 5. Volume equals length times width times height. So that's going to be 5 times 5 times 5. Or sometimes they might say side cubed, which means the side times the side times the side. Okay, so we say cubed, or to the third power, raised to the third power. Once you get to a 4, there's no special word like squared or cubed for it, so you just have to say 9 to the 4th power, or 9 to the power of 4. Okay, so A says use an exponent to write each expression. So the number that is being repeated, that keeps appearing in the expression, is going to be the base, the big number. Big base. Okay, this problem is all about that base, Okay, that was terrible. I probably would embarrass my kid if she heard me sing that. Okay, so how many 3s are there? There's 5 of them. So that's 3rd to the 5th power. Put the little 5 right there. That looks bad. 3 to the 5th power. Okay, so it says find the base, or the number being multiplied. The base is 3. There we go. Find the exponent by counting the number of 3's being multiplied. So there's 5 factors of 3. So it's 3 to the 5th power. So yeah, in your notes, you're going to write 3 times 3 times 3 times 3 times 3 equals 3 to the 5th power. Let's look at B. What is the factor that's being repeated over and over again? The factor that's being repeated is 4/5. Okay, and how many 4/5 are there? There's 4 of them. Now, fractions are kind of tricky, because if I put a 4 here, that might mean just the numerator, and then the denominator doesn't get multiplied too. So if you mean for all of that to be repeated 4 times, and I do because it's all there 4 times, then you put parentheses around it, and then when the little 4 is sitting on the outside of the parentheses, that means everything inside the parentheses being taken 4 times. If you didn't put the parentheses, that would mean 4 times 4 times 4 times 4, but then the 5 is only there once. Okay, that's not what we're doing here. Okay, this is the answer. And oh wow, look, there it is. I was right. So in your notes, write down these 2, 3, 4, and 5. And let's do those. Okay, number 2, that's going to be our base is a number that's being repeated, so that would be 4. And then count how many there are. 1, 2, 3, 3. Okay, number 3, 6. There's only 1, so it would be 6 to the 1st power. Number 4, the 1/8 is being repeated. How many are there? There's 2. Now, 1 and the 8th, both the numerator and denominator are being repeated, so you have to put parentheses around that. And then number 5, the base is 5, and then 1, 2, 3, 4, 5, 6. So 5 to the 6th power. You've always wondered what my cat Well, this is Isabella's cat, what he looked like. Say hi. Say hi, Max. Max. Oh, now you don't want to talk. No. Finding the value of a power. So now we're actually going to multiply those things out. Okay, now this is something that I learned in high school. So, wow, you guys are learning it really early. 5 to the power of 0, that's equal to 1. Okay, and I can't remember the explanation for that. I can't remember the rule, so I guess I'm going to have to Google it to refresh my memory of why 5 to the 0 power is equal to 1. I can't remember. Okay. But yes, put this in your notes, in your Cornell notes. Write that down. 5 to the 0 power equals 1. Anything to the 0 power is equal to 1. So if I have 3,645 to the 0 power, that's equal to 1. Okay. So example 2 says find the value of each power. So that's -10. And how many times are we going to repeat it? Times -10 times -10 times -10. These parentheses right next door to each other like that is another way to write multiplication. So let's take 10 times 10 times 10 times 10. Real quick, easy way is a 1. And then let's count how many zeros there are. 1, 2, 3, 4. So that's how many zeros are going to be my answer. 1, 2, 3, 4. Oops. And then we need to figure out if it's positive or negative. So negative times a negative is positive. Negative times a negative is positive. A positive times a negative is negative, and negative times a negative is positive. Another way you can tell is that there's 4 of them. 4 is an even number. Anytime you have an even number of negatives, your answer is positive. Okay. Wow, we're getting some complicated math. We're having to like really remember those rules that we were supposed to have learned at the beginning of the school year. So 4 tenths to the 3rd power means 4 tenths. Yes, you're writing these down in your notes. Times 4 tenths times 4 tenths. How nice that there's no positives or negatives. I mean, they're all positive. So let's do this right here. 4 tenths times 4 tenths. Okay, 4 times 4 is 16. Carry the 1. And then 4 times 0 is 0. Plus 1 is 1. And then let's start the next row. I'm going to put my 0 there to begin with. Now 0 times 4 is 0. 0 times 0 is 0. There's my second row of products. Add them together. 6, 1, 0. And then I have 1 decimal number here, 1 decimal number here, and that's going to give me 2 altogether. So I need to make sure that I have 2 in my answer, and that's 1600ths. So that's just when we've taken it twice. I didn't get the same answer as this one. I was freaking out a little bit. Okay, so that's just 4 tenths times 4 tenths. Now we need to take that answer times another 4 tenths. It's pretty much like 16 times 4. Carry my 2, that's 6, 0. Okay, there's my first row of products, and now let's do the second row. I'll start with a 0 there, and then 0 times 6 is 0, 0 times 1 is 0, 0 times 0 is 0, and I add those together. I hope that you're really processing and you're not just copying down. Okay, that because you're going to have to do this on your own. I'm not going to make a video for the STAR test while you're taking the STAR test. There's 2 decimal places there, and there's only 1 decimal place there. So together that's 3, 1, 2, 3. And there's your final answer. Yes, all that needs to go in your Cornell notes. So if you didn't get it, you better go back and write it down. I'm going to be looking for it. Okay, for C. Oh, this one's easy. Look. Anything to the 0 power is equal to what? 1. Okay. Hopefully I'll have an explanation for you. I just can't remember it right now. My brain is tired. Okay. D. I can't believe they're throwing this at you. Y'all are just little 6th graders, and I didn't learn this until I was in high school. But, gotta do it anyway. On D, so sorry, I'm sure that's super loud. It's saying negative 11 to the 2nd power, or remember that word, squared, if it has a little 2. There's a difference between that and that. Okay, and they're not the same thing. The 2 is only squaring the 11. It's not including the negative sign. Okay? So that means that it's negative, and then we're taking 11 times 11. That's what it's telling us to do. And some students might think that it's negative 11 times negative 11. That's what the second one means. And that's not the question that they gave us. The question that they give us is just 11 squared, the opposite of 11 squared. So let's find out what 11 squared is. Well, that's a math fact, right? That's 121. Okay? 11 times 11 is 121. And then this is the negative sign. Over here, this would be, remember, a negative times a negative is a positive, so that would be positive 121. See how they're not the same? And this answer here is the one that they were asking for. Okay? So, enter. 3 times 3 times 3 times 3. Okay, 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 51. Number 7, that's saying negative 1 is being used as a base 9 times. Oh man, you know what? We know that a whole bunch of 1s multiplied together is going to be a 1. So let's just put a 1 there as our answer. And now we have to figure out if our answer is positive 1 or negative 1. Earlier, I reminded you of a rule that if it's an even number of negatives, it comes out as a positive answer. But this is giving us 9 negatives. There's going to be 9 negatives here. And that's an odd number of negatives. So when you have an odd number of negatives, your answer is negative. Remember our Chinese Dorito? How many negatives are here? 2. And 2 is an even number, and that gives us a positive answer. Okay, number 8. 2/5 times 2/5 times 2/5. Here we go. 2/5 times 2/5. Yes, you put all of these in your notes. If you didn't do that, you better go back and do it now. So let's multiply our numerators. What's 2 times 2? 4. 4 times 2? 8. And then let's do our denominators. 5 times 5 is 25. 25 times 5 is 125. This is major math that you guys are doing. Okay, and then number 9, negative 12 squared. Okay, remember, this doesn't have a parentheses around it like that. If it did, that would mean that it's negative 12 times negative 12. It doesn't, so it's just multiplying 12 times 12, which is 144, and then that negative.